we have 1 over 1 plus sine x plus 1 over 1 minus sine x. Because we don't have like denominators, we have to make equal denominators before we go ahead. So I can multiply this fraction by 1 minus sine x, and I can multiply this fraction by 1 plus sine x. What happens if I multiply both top and bottom by 1 minus sine x? 1 minus sine x times 1 is 1 minus sine x. And 1 minus sine x times 1 plus sine x is just 1 minus sine x, 1 plus sine x. Let's leave in multiplication form for now. Plus, we're going to do the same. 1 plus sine x times 1, 1 plus sine x times 1 minus sine x. 1 plus sine x times 1 is 1 plus sine x. And 1 plus sine x, 1 minus sine x. Now we have the like denominators or common denominator, so we can merge these two fractions. So what we have on top is 1 minus sine x plus 1 plus sine x. And in the denominator we have 1 minus sine x times 1 plus sine x. On top, negative sine x cancels positive sine x because we're adding, and 1 plus 1 is 2 on top. In the bottom here, we have difference of two squares. If you have a squared minus b squared, that is equal to a minus b times a plus b. In our case, this is our a term, this is our b term. It looks like our right-hand side. So we can compact it like a squared minus b squared, which is going to be 1 squared minus sine squared x. Now we know that 1 minus sine squared x is equal to cosine squared x by the Pythagorean identity, because sine squared x plus cosine squared x is 1. Here, if you solve for cosine squared of x by subtracting sine squared of x on both sides, you get 1 minus sine squared of x. So I can rewrite 1 minus sine squared x as cosine squared of x using the Pythagorean identity. So I have 2 over cosine squared of x. What is 1 over cosine squared of x? We know that 1 over cosine squared of x is secant squared of x by the reciprocal identity. So here I can write as 2 times secant squared of x. That's my final answer. Because this fraction is 2 times 1 over cosine squared of x, which is 2 times secant squared of x. Let's check out problem number 24. We have tangent theta plus 1, the quantity squared. By the binomial squares, we know that a plus b quantity squared has a squared plus 2 times ab plus b squared in the expansion. If you have the negative 1, a minus b the quantity squared, same formula with negative sign. So here our a term is tangent, our b term is 1. So square of the first one is tangent squared theta plus a times b, double it, so 2 times tangent theta times 1, and square the second term. 1 squared is 1. Now we can combine tangent squared theta plus 1. We know that tangent squared theta plus 1 is secant squared theta by the Pythagorean identity. So I can merge it as secant squared theta plus 2 tangent theta. This is all we can do for this problem. There is no more simplification. Let's check number 25. We have sine squared theta minus 2 sine theta plus 1. It looks like our a minus b the quantity term squared. So it's like a squared minus 2 times ab plus b squared. In our case, our a is sine theta and our b is 1. So it's like a squared minus 2 times a times b plus b squared. So this is like sine theta minus 1 quantity squared. Number 26. We have cosecant theta minus sine theta over cosecant theta. Here the idea is to express everything in terms of sine and cosine. We know that cosecant theta is 1 over sine theta. So I can rewrite cosecant theta as 1 over sine theta minus sine theta here over 1 over sine theta. I need to merge these two fractions here. So you can shortly, like a over b minus c is b times c, a minus b times c over the same denominator. So sine times sine, sine squared theta, 1 minus sine squared theta over sine theta, all over 1 minus sine theta. Now we know that 1 minus sine squared theta is cosine squared theta by the Pythagorean identity. So I can replace it as cosine squared theta. And I have sine squared theta here. That is, I'm showing not negative sign. And 1 over sine theta. Now we can do keep change flip. Keep the first fraction. Change division to multiplication. Flip the second fraction. Now sine cancels sine. The answer is cosine squared theta. Problem number 27. We have sine squared theta over 1 plus cosine theta. What can be the idea here? In this problem, we have sine squared theta over 1 plus cosine theta. Let's rewrite sine squared theta as 1 minus cosine squared theta using Pythagorean identity, because we know that by Pythagorean, sine squared theta is 1 minus cosine squared theta. And I have 1 plus cosine theta here. I know that the one on the top is difference of two squares, like a squared minus b squared. The first term is the perfect because 1 squared is 1. The second one is perfect, cosine squared theta. And we have minus sign in between. So it's a minus b times a plus b by Pythagorean, by the difference of two squares formula. So it is 1 minus cosine theta times 1 plus cosine theta. And we have 1 plus cosine theta here. 1 plus cosine theta cancels 1 plus cosine theta. The final answer is 1 minus cosine theta. Problem number 28. We have cosecant squared theta minus 1 over cosecant squared theta. There are a few directions in this problem. You can either express everything in terms of sine and cosine and then merge, or you can use Pythagorean identity, cosecant squared theta minus 1. You can express cosecant squared theta as 1 plus cotangent theta. Or you can separate the fractions. You have two terms in the numerator and one denominator, which is common denominator. Let's go that path because cosecant squared and cosecant squared cancels each other. So I'm separating the fractions here. If you have 5 plus 2 over 7, you can rewrite as 5 over 7 plus 2 over 7. So it's going to be cosecant squared theta over cosecant squared theta minus 1 over cosecant squared theta. In this problem, we have cosine. Problem number 28. In this problem, we have cosecant squared theta minus 1 over cosecant squared theta. We have a few directions in this problem, which will yield to same answer. We can express either everything in terms of sine and cosine, and then do the algebra, or we can use Pythagorean identity for cosecant squared theta, and then do the simplification. Or we can separate this fraction because we have two terms in the numerator and one term on the denominator. It is like 5 plus 2 over 9. You can express it as 5 over 9 plus 2 over 9. You can separate this fraction. So we can do that because it's going to be easier because we have cosecant squared that cancels. So let's separate this fraction. Cosecant squared theta over cosecant squared theta minus 1 over cosecant squared theta. Cosecant squared theta divided by cosecant squared theta is 1. And 1 over cosecant squared theta is sine squared theta by the reciprocal identities. So I have sine squared theta here. And we know that 1 minus sine squared theta is cosine squared theta by the Pythagorean identity. So this is our final answer. Problem number 29. We have tangent theta, secant theta, sine theta. Let's rewrite everything in terms of sine and cosine. We know that tangent is sine over cosine. We know that secant is 1 over cosine. And we have sine theta here. So multiply sine theta times sine theta on top is sine squared theta. Cosine theta times cosine theta is cosine squared theta. Sine squared theta divided by cosine squared theta is tangent squared theta. That's our final answer. Problem number 30. We have multiplication and we have two different denominators. So 1 minus cosine theta divided by 1 minus cosine theta, there is a purpose here. So we don't simplify this directly, or else our problem is gonna be like sine theta divided by 1 plus cosine theta, dead end. So let's multiply top by top, bottom by bottom. Sine times 1 is sine theta. Sine times negative cosine is negative sine theta cosine theta. Here we're going to do the same. This is difference of two squares because we know that a minus b times a plus b gives us a squared minus b squared by difference of two squares. So square of the first one is 1 minus square of the second one is 1 minus cosine squared theta. In the bottom, we know that 1 minus cosine squared theta is sine squared theta by the Pythagorean identity. And on top, we have sine theta minus sine theta times cosine theta. First, let me write sine theta minus sine theta times cosine theta. In the bottom, I have sine squared theta. We can separate this fraction because sine squared theta is common denominator. Sine theta over sine squared theta minus sine theta cosine theta over sine squared theta. It is like again a plus b or a minus b divided by c. You can separate it. So sine divided by sine squared theta is 1 over sine theta. One factor of sine cancels this sign. Here again, sine cancels one factor of sine squared theta. So we have sine theta in the bottom. We have sine theta in the bottom. Minus, we have cosine theta over sine theta here. We know that sine theta, 1 over sine theta is cosecant theta by the reciprocal identity, and cosine over sine is cotangent. I think we can leave it in this form. Okay, let's see another problem. Sine squared theta times 1 plus cotangent squared theta equals to 1. We're going to verify this identity is equal to 1. Okay, let's multiply out. Sine squared theta times 1 is sine squared theta. Sine squared theta times cotangent squared theta is sine squared theta, cotangent squared theta. Now, maybe we can express everything in terms of sine and cosine. Let's rewrite everything in terms of sine and cosine. Sine squared theta plus sine squared theta. Cotangent is 1 over tangent, which is cosine over sine. Okay, now I can do this cancellation. Now I'm left with sine squared theta plus cosine squared theta, and we know that it's 1 by the Pythagorean identity. Left hand side is 1, right hand side is 1. Checks. Number 32. We have cotangent theta, secant theta, cosecant theta. We're going to verify that's equal to 1. Again, let's express everything in terms of sine and cosine. Cotangent theta is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. Cotangent is cosine over sine by quotient identity. Secant is 1 over cosine by reciprocal identity. And cosecant is 1 over sine by the reciprocal identity. Here we're multiplying, so cosine cancels cosine. And I have 1 over sine divided by 1 over sine. Exact same quantity divided by itself. Then you have 1. Checks.